Hi there, my name is Aaron Lanterman. This video documents my attempts to reproduce a famous Synclavier patch in the Moselle software synthesizer. In addition to being a great ear training exercise for sound designers in general, trying to reproduce a patch from one synthesizer in another synthesizer is a good way to both learn more about the original synthesizer and learn more about the target synthesizer. In this case, I've been fascinated with the Synclavier ever since I started lusting after it in Keyboard Magazine, like a lot of teenagers in the 1980s who were into synthesizers probably did. And I took this as a learning opportunity to learn more about Moselle, and so this video serves as a bit of a Moselle tutorial. The patch goes by many names. In the Synclavier Go app, it's called Galactic Cymbal. On some old discs, it's called Bass Tambourine, but I think it's most commonly known as phased gong. An original Synclavier voice could consist of up to 4 partials, although later software versions of the Synclavier architecture and the modern region synthesizer extended that to 12. Each partial consists of a modulator-carrier FM synthesis pair. So the use of the term partial here shouldn't be confused with the way people use the term partial to refer to overtones. So a 3-partial Synclavier patch could emulate algorithms 5 and 6 from a DX7, although I should mention that the Synclavier doesn't have feedback. The main trick the Synclavier has up its sleeve is that its carrier can consist of a single cycle waveform that you define by defining the amplitudes and phases of 24 harmonics, whereas the DX7 carriers were all just sine waves. Now, the original Synclavier restricted its modulator to also be a sine wave, although the new software versions and the region let you have complex modulators. One thing I need to warn you about, and that tripped me up for a while, is that these bars and the numbers you see in the lower left corner are not on a linear scale. According to Cameron Jones, this sort of morphs between a square root and a cube root kind of scale so that you can have more precision at the lower end when trying to move these bars up and down. I found this to be really confusing. So I'm going to pull the harmonic amplitudes off of this old school text-based display. Fortunately, the timing information for the envelopes, which is given in milliseconds, seems to match what I see in the GUI here. Okay, finally, here's the patch. So for my carriers, I'm going to use SWOs, which are the stored waveform oscillators. In Moselle, you can take the name of a block and add some other letters to it to make different instances. So here I'm just using numbers. So with harm 1, harm 2, harm 3, etc., I can set the harmonic levels. Very importantly, this just resets whatever the existing basic harmonic for your waveform is. So you have to put in Waveform None. I had a bug where on this particular oscillator here, I forgot to put in this line, so it defaulted to a sawtooth wave. So for harmonic 9, harmonic 10, and so on, I had sawtooth harmonics, which do indeed slope off pretty quickly, but there's enough of those that once the FM gets going on, I got all sorts of crazy junk aliasing sounds. So putting in waveform equals none fixed that. And I think that's pretty typical of a lot of Synclavier patches. They tend not to use a lot of the higher order harmonics when they use FM because you get these aliasing issues. Now, the SWO block has some tricks up its sleeve that it uses to try to avoid aliasing, but that assumes you're keeping the frequency well behaved and not doing freaky modulation things to it, so you do get some aliasing. So on one of these oscillators, if you don't specify the frequency, it defaults to the output of the pitch module. Now, Moselle has a convention where there's default outputs you can use, so I can actually leave out the colon output here. And since this frequency equals pitch, output is the default, I can leave out this line entirely. But oscillator 2 is detuned slightly, so that's why you see this 441.1 divided by 440 here. And oscillators 3 and 4 are pitched down an octave and also detuned. So this is information I got from the Synclavier patch. Now, all digital synths that use frequency modulation technically use phase modulation, so we're going to set the PhaseIn variable here. So os here, the way I'm using it here, this is kind of like an anonymous module. We're not naming it. So I have the pitch here, and we have a FM ratio of 3.496, and we're telling it to use a sine wave. Otherwise, this will default to a sawtooth. Now, I'm using what's called the control output. If I were to change this to the regular output, then that would have a thing where above a certain note, it actually starts ramping down the amplitude as you go higher in frequency, but I don't want that here, so that's why I'm using control. So the ADSR envelope, that's going to create an output between 0 and 1. The oscillator output goes between -1 and 1. I'm multiplying this by 1.6 to define the actual amount of modulation. I have no idea how the numbers in a Synclavier patch map to actual numeric indices of modulation, so I just tuned this 1.6 by ear. Essentially what I did was I set this to 2 times one of my MIDI control knobs, and then I turned that until it sounded right to me, comparing it against the Synclavier patch. Your mileage may vary. Now, if we wanted to, we could have created a named oscillator. I could have called this something like os M1 for modulator 1 and use that down here instead. I could set the frequency, let's see if I can spell frequency, equal to 3.496 times pitch. And I could have set the waveform equal to the sine, but it's just as easy to here have it all in one line. Basically, because I don't need to refer to the output of this anywhere else, it makes sense to use an anonymous module. If I needed to use the output of this multiple places, then I would want to create a named module. Now, the FM envelopes on partials 1 and 2 are pretty complicated, so let me go to 3 and 4. So here you can see that I'm creating an anonymous ADSR envelope. So I have an attack, decay, sustain, release, and you can see I can put in units of milliseconds here. So there are different outputs from this ADSR. If I want all of the segments to be linear, I could just use output here. There's also an EXP output where the attack and the decay are both exponential, and then there's an amp output where the attack is linear, but the decay is exponential. And when I say decay here, I also mean the release. Now, when I tried amp, it didn't quite sound right. It sounded like it was decaying too quickly at first relative to the Synclavier patch. But when I tried the linear output, it sounded too slow. So I messed around with it a bit, and it seemed to sound most accurate to me if I squared the output here. So I did some Googling, and I found this passage in the region manual that says the Synclavier 2 decay was an approximate parabolic curve, since it was efficient to compute on the hardware of that time. So I don't know the exact details, but I'm guessing with that square, I'm kind of on the right track. In the region, you can also set it to be a logarithmic curve. There, they really mean exponential curve. It's sort of like how a log pot really has an exponential response. But it looks like in the region, you can also set a linear slope. Now, what's interesting is if you're using the plugin version of the Arturia Synclavier V and you're using the controls view, there is this parameter here for each of your partials that says decay shape. And you don't have a linear choice, but you can either match Synclavier 2 envelopes or you can use a true exponential. Now, the interesting thing is that as far as I can tell, there is no way to access that parameter from the main GUI, which means you also can't access it from the standalone app. So those are our FM envelopes, and I can make them anonymous because I only need the output of them in one spot. For the amplitude envelopes, it's a little bit more complicated. Ignore all this 1.44 to the power of NoteNumber stuff for now. We have attack, decay, sustain, release. I have 4 amplitude envelopes, and the way I use these is I just take each of the outputs of my oscillators and I multiply those outputs by the outputs of the envelope, but I also need to do that squared thing to get the parabolic response. Here I'm also multiplying each of those outputs by one of my MIDI controls, so these are numbers between 0 and 1. And that way I can turn up and down the individual partials and check out what their effect is. The 0.655 is here because the ADSR envelope doesn't offer an obvious place to put a peak number. And this particular envelope peaked at 0.655, unlike the others that peaked at 1, so I shoehorned it in here. Since I'm adding up the result of 4 oscillators, each going between -1 and 1, I also multiply by 1/4 here to keep the result between -1 and 1. Now, the envelopes, in addition to producing their analog output value, they produce a logical value called finished that says when they're done. And here, I want to make sure that the voice doesn't stop until all of the envelopes are finished. If I have this set up so that maybe one of the envelopes ends earlier than the others, then it's going to cut the voice off when the other should keep going. So here, we only declare the voice finished if all of the envelopes are finished, which I do with this logical AND operation. Note that I'm using the control output of the oscillators, so I don't get that effect that you use with the regular output, where above a certain note, Moselle starts ramping down the amplitude with frequency, because I don't think the Synclavier does something similar. Now, notice here I couldn't use anonymous envelope generators because I need the outputs in 2 different spots. I need the main analog output here. Okay, it's not analog, but you know what I mean. And I need the finished output here. SWOs don't have a sync output, so to trigger the scope, I created a dummy oscillator using a pitch that's half the main pitch because a couple of the oscillators are pitched down an octave. My scope is a little bit janky. If you'll notice in the beginning demo when I was showing the scope plot, I tried to wait until a note entirely decayed before pressing another one, because I found that pressing a new note while the previous note was decaying, it's like the scope wouldn't catch the new note at first. If anyone has any ideas on improving my scope code, leave a comment below. Okay, now for the complicated bit. On the release here, you'll see this 1.44 to the power of minus note number minus 69 divided by 12. Oh, actually this is a bug. In my experiments, I found I needed to multiply decay here by something like 3 to make it sound right, and I just realized the issue is that this business with the note number that I included in the releases, that also needs to go on the decays. Let me fix that. I'm going to go away for a bit and fix that. I'll be right back. Okay, I'm back. It wound up being a subtle change. Anyway, what is all of this business with the 1.44 to the power that you'll see in the decay and release formulas for the envelope and in the decay and the release formulas? Well, okay, not for oscillators 3 and 4, but for 1 and 2. So you'll see it here for the decay and see it here for the release. So this is something that took me ages to figure out and was really frustrating. I kept trying to get my Moselle patch to match the original Synclavier patch, and I just found the envelopes weren't long enough. And then I spent some time playing the original patch in the Arturia Synclavier V, and I found out that basically as you play lower and lower on the keyboard, the envelopes get longer and longer, and as you go up the keyboard, they get shorter. In the Synclavier Go manual, I found this sentence: you can change how long a partial takes to decay based on what keyboard note is hit by raising the decay from 100%. So this isn't the main decay time for the envelope. This is some weird hidden parameter. A4 is considered the baseline for decay. But this didn't give me a lot of information about how this is actually implemented. Now, the region manual calls this parameter decay adjust, and it says that the units are a percentage of decay per octave. Here, however, it says that the reference note is middle C. I couldn't find any similar reference in the Arturia Synclavier V manual, but if you look in the controls view, there is this decay adjust parameter that's 1.44 for partials 1 and 2 and is 1 for partials 3 and 4. Much like the decay shape parameter, this is something only accessible in this view. It doesn't look like it's accessible from the main GUI. If you do know where this is in the main GUI, please leave a comment below. So that's where I got the 1.44 from. And in my experiments, it seemed like the A above middle C seemed to be like the center point. So that's the point where this time is correct. And then you scale around that. So here I divide by 12 to compute a number of octaves. And I take 1.44 to the power of that number of octaves. And I want this overall number to grow for the lower notes. So that's why I put the minus sign here. So if you have any inside information about a more correct way of treating this, for instance, if I need to use a different number here for my MIDI note, or for that matter, a better way of treating the envelopes, let me know in the comments below. Now you're probably thinking to yourself, why am I copying and pasting this bit of code? I should be able to define some sort of local variable and copy this here and then use the word local variable in those places. And I think you're supposed to. There's user variables, but when I tried to do that, I got an error message. I don't know if that's a bug in Moselle or if that's a bug in my understanding of Moselle, but you are supposed to be able to do stuff like that somehow. Anyway, we'll call this close enough for now. Oh, one other thing that I should mention, just a bit of nomenclature. I meant to mention this earlier, but I forgot. The envelope you use for the modulation amount, that's an envelope the Synclavier calls the harmonic envelope, which should not be confused with these harmonics. Yeah, it's very confusing. The patch is fairly dynamic, not in terms of velocity. There's no velocity sensitivity here, but in terms of how long you hold the note. So here I'm just going to barely touch it. Now I'm going to hold it a little bit longer. And now I'm going to hold it very long. You'll see there the scope is having trouble keeping up, I think. Not sure what's going on there. Anyway, let me break down the individual partials. Partial 1 is the main bulk of the tone. So here's what it sounds like barely touching it. Holding it longer. Now, partial 2 sounds almost the same, except it's a much faster decay. And in fact, the decay is so fast that if I press and hold it, you just get this percussive thwack. If I just barely touch it, then the decay doesn't get all the way down, and then the release has something to work with. In any case, I have trouble hearing partial 2 in the patch. Here's partial 2 and partial 1. Here's just partial 1. The only time I really hear the effect of partial 2, at least in my implementation, is if I just barely touch the note. So here's partial 1 by itself. Now let me put in partial 2. Let me take out partial 2. And put it back in. So if I hear it at all, I hear it as just a really subtle chorusing when I barely touch the note. So here's timbre 4 by itself if I hold down the note. And here's what I get if I barely touch it. So when I barely touch it, the decay doesn't get very far before the release kicks in. But if I hold down the note, then it decays all the way to 0 and the release can't kick in. Timbre 3 is basically a detuned and quieter version of the same thing. So here's timbre 4 again. And here's what I get when I mix in timbre 3. So it basically gives a slight chorus effect. Here's what I get if I have timbres 1 and 4. And here's just timbre 1 again. So that lower octave percussive thwack gives it more attack. Let me put timbres 2 and 3 in. So this is now the full patch. I'm going to include the code in the description below. So if you haven't already tried out Moselle, you should first of all download it, install it, try it out, and try out my patch and start tweaking it. See if you can get it closer to the original Synclavier sound. And you can also use this as a springboard to do all sorts of weird things that the Synclavier is not capable of. If you want to go down this rabbit hole, I strongly recommend watching this breakdown of the phase gong sound by Anthony Marinelli. If I were to spend more time on this myself, I would probably start by adding the Synclavier chorus effect. And on the Synclavier, chorus is basically achieved by just making another copy of the patch and detuning it slightly and playing it at the same time on another voice. And you could probably simplify that here by just taking partials 2, 3, and 4 and keeping those mono, but maybe making a stereo version of partial 1, panned left and right, just slightly detuned.